Okay, so we're going to finish up the last two, and you need to have your little half sheet of green handy so you know where this is coming from, because remember, this isn't magic that I'm just deciding what's what here. I know, it sounds like magic, but it's not. Okay, so let's look at number 11. On number 11, how many terms are there? And how many terms? There are two terms. There is one here and one there. Two terms, right? Your terms are separated by addition and subtraction. There are things multiplied together in that second term, but there's just two terms, right? So, before we start substituting anything, let's use some algebra skills here. Do those two terms have anything in common? Tangent squared of y, right? They both have tangent squared y in there. All right, so when you have two terms that have something in common, what do we call that? No, like terms mean that they're yeah. But they have one thing, or they have the most in common when we're factoring. What's it called? GCF, right? So we have a GCF. We could factor it out. Does that make sense to you? So they both have a tangent squared y in it. I can factor out the tangent squared y. And when I do that, what am I left with in the first term? 1. And what am I left with in the second term? Sine squared y. Okay, right? Because whatever I do here, if I distributed that back in, I should get back to where I started from. Make sense? Everybody good with that so far? Okay. I factored that out. So that's like if I had 3 minus 3x, I can factor the 3 out and get 1 minus x. Right? And then if I distributed this back in, I'd get that. So if I distributed this back, tangent squared y times 1 is tangent squared y. Tangent squared y times sine squared y gives me that. Everybody with me so far? Just factoring out a GCF. All of your algebra skills remain exactly the same. So same stuff you've been doing forever. But remember, we're trying to condense this down to one term here. So is there something that I can substitute this 1 minus sine squared y with? And you staring at me doesn't do you any good. Look at this. Is it cosine? Just cosine? Cosine squared y. Because cosine squared plus sine squared equals 1. So then this gives me tangent squared y times cosine squared y. Okay, everybody good so far? I can change tangent into a quotient. What is tangent in the quotient form? Sine over cosine. So this would be sine squared y over cosine squared y times cosine squared y. Basically over 1. Yeah, I think that helps sometimes. And then what can I do? Cancel these out because it's multiplication. And we are left with sine squared y. And we're done. Okay. Everybody good so far with that? All right, so let's look at number 12. In number 12, can I cancel anything out here? No. And even if I could, like, there's subtraction here. So, like, let's say this said sine squared or sine cubed x down here. I couldn't just cancel those out. Like, that's a big fat no, all right? But when I look in the numerator, how many terms do I have in the numerator? 2. Is there anything I can factor out? Sine cubed, yes. So sine cubed x, and then that leaves me with cosecant squared x, then what? Is that it? Minus 1, good. All over cosine cubed x. Now the numerator is one big term. Okay, does that make sense to you? Within it, there's other things, but that's like one big thing there with multiplication. So now, if this was sine cubed, which it's not, but if it was, then I could cancel these out now. There's a different thing there, right? So I can't cancel it out. However, isn't this the same thing as sine? Okay, you want to put cotangent in there? Okay, we'll do that. So let me back up a little bit. No, that's okay, because we can do it in different order. We're going to do the same thing, but it doesn't matter what order. So sine cubed x times, and this can be, what did you say? Cotangent, good. and cotangent squared x, so make sure you're keeping up with your squareds, cubes, things like that, over cosine cubed x. Everybody okay with all that so far? All right. So then I can make this sine cubed x over cosine cubed x, right? Times cotangent, basically. And what is cotangent? Cosine over sine. So instead of me writing times cotangent squared x, do you understand how I can basically pull that out and just make this cotangent right here? But since it's cotangent, I'm going to make it cosine squared x over sine squared x. Then can I simplify things? I actually can. And again, because this is multiplication, make sure you understand that part. I can cancel this cosine squared out with 2 of these, which leaves me 1 cosine in the denominator. Sine squared with 2 of these, which leaves me 1 in the numerator. So that leaves me with sine x over cosine x. And what is that? Tangent of x. Tangent. All right. Everybody good with all that? Ask me questions if I lost you somewhere. When you do this stuff, you cannot be afraid to write stuff down. Oh, I was just going to, instead of doing cotangent right here, I was going to write this out in front first. I wasn't going to, it was going to be the same thing. Just do that part first. No, I'm going to skip a step. I was going to do this step before this step. I was going to write this out here times cosecant squared x minus 1. It's not any different. Like, in the end, there's different, there's different orders you can do things in sometimes, and you get the same thing in the end. It wouldn't be. Oh. Okay, questions. All right, so here's the deal. If you've already started on this homework and have some of it done, don't freak out when I'm about to say what I'm about to say, because it'll, let me finish. Right now, I really just want y'all to do the odds. If you have already done some of the evens, I will count them as extra credit. Or if you finish the odds and then you want to do some evens because you have time for extra credit, you can do that, okay? But before that, I'm going to show y'all 2 things, okay?